In this video, we're going to take our bracket and we're going to put it into an assembly. And I'm going to make the assembly so that you can see some of the features of the Assembly Workbench and get you started there. I'm not going to do anything too complicated, but I'll do some of the joints so that you can see what's available to us. We want to make sure that, when you get started with your assemblies, that you have a good experience. Is the Assembly Workbench perfect? I would say no. Is it a fantastic step forward from where we were with bunches of different assembly workbenches? Absolutely. So we're going to take a look at it. We'll see what it looks like and how we put an assembly together. Okay, before we start with our assembly, I just want to show you a couple of the things I've already created so that we can assemble them. I have a back plate. It's literally just a plate with some holes in it to fit the brackets onto. I have a pin, which is going to go into each of those holes. So the pin, just a very simple pin. It could be a screw, it could be whatever you want it to be. And I have a face plate, which is the plate that's going to go on the front, and we're going to make that slide. So that's the piece that's going to fit on the front. Again, I just made these parts so that I could use them in the assembly. They're not engineered in any specific way. I just made them so that they work as part of an assembly. To turn off your model, you just hit spacebar, and that's going to turn that off. The first thing we're going to do is we're going to go into the Assembly Workbench. Notice I'm not going into Assembly 4. I'm going into Assembly. This is the one that's included with version 1. And I will tell you that I'm now using the actual release, FreeCAD 1. And so anything that you see here, if you download the latest release, because FreeCAD 1 has been released, you will have those tools. So again, in my assembly, first thing I want to do is to create an assembly. If you notice, remember we showed in previous video, when you go into a workbench, your toolbar changes. And in this case, they're grayed out if they're not applicable. If I don't have an assembly, I can't use any of these parts. So what I'm going to do is I'm going to create an assembly. That literally just puts in an assembly into my tree, and then it gives me a folder for where my joints will go. There are no joints in there yet until we get something added. The next icon along is to insert a component. Now what I've done is I've created some components in this file, in the bracket assembly file, but I'm also going to include the bracket out of my previous bracket video file. So I have that open already. If you don't have it open, you can open a file as part of the insert parts, but I'm not going to do that. I'm just insert components. So here I go. I'm going to click on the insert components, and you can see the options over here for things that we can include. First thing I'm going to include is this back plate. Now the reason I'm doing that first is because when you put the first thing in, it's going to say, do you want to ground the first inserted part automatically? I don't do it always. What I do is just say yes. So I can do it on a case-by-case basis, just in case I bring in the wrong thing. But this is, everything would be fixed to this back plate. So I'm going to say yes to that. Notice also when a part comes in, you can move that around. Now, one thing I want to point out is the difference between a part and a body. So these are actually bodies that I'm including. They're inside parts for me, so I could include the whole part and it would bring one of everything in. But what I'm doing is I'm taking the bodies because I have different amounts of those to come in. Now, what I've found in using the assembly is don't just bring everything in one go. It makes it too complicated, too many parts all over the place. It's going to give you a headache. So the first thing I'm going to do is going to bring in my brackets now. So I'm going to bring in 3 of those. And when they come in oriented the way they are in their model. I'm not going to change that right now. I'm just going to bring in 3 of them. Notice when it brings them in, it spaces them out too, so they're not all on top of each other. That's helpful for when you're doing your alignment. Now what I'm going to do is I'm going to attach a bracket to a back plate. Now one of the things that I've noticed with assembly is you do need to be able to move around in that assembly quite a lot. So you need to be able to rotate things, and you need to be able to get comfortable with sometimes when you rotate something, it moves out the way. You might want to hit this button that we've used before. It's the fit all. If you do that, it'll keep bringing it back to the middle so that you can then rotate from there. So just be aware that you're going to be doing quite a bit of moving around as you're connecting these things. Now, one thing I would say is it is very helpful for you to move the part that you want to attach close to the attachment point. So I'm going to do that. And to move these parts, I just go over into my tree and I'm going to close that one there so that you can see. This is my assembly tree. Here are my parts. And you notice as I arrow over them, they light up. So if I want to take that one, I can click on it and notice my arrows are all lit up there. So I can just simply move it. Going to bring it fit all. Going to zoom in there a little bit. My setup is Blender, so I have my scroll wheel zooms me in and zooms me out. And then I can take this little blue thing for rotation, so I can rotate that around to roughly where I want it to be. And it's just helpful as you put the parts together. You don't have to go all the way in front of it. It doesn't have to be right in the position. So now I have it somewhere close to where I want it. What I'm going to do is I'm going to say OK over here. Those are my parts already in. And I'm going to just assemble these parts before I bring anything else in. So what I'm going to do, the first joint that I'm going to create, so these are your joints over here. I'm going to create what's called a fixed joint. So if you put a fixed joint in, it locks two parts together and it prevents any movement at all. So there's no rotation and it can't move in or out. So if a part is on a fixed joint, the only way you can rotate is actually from the joint. I'm going to show you that because when you put these together, sometimes they flip back to the way they were. So I'm going to show you that. So for a fixed joint, I'm going to go into this hole. I'm just going to click on the outside edge of that hole. And then I'm going to go to the other side of this hole. It's important that you do this. If I did it to the front of this hole, it would actually connect it at that front plane. We don't want that. So we want to connect it at this spot here. So I'm going to click that. And then immediately the part goes over and locks itself onto that hole. And you see what I mean by having to move around a lot. Now, one thing to note, it flipped back around. Did you see that? It's flipped back into that orientation. Even though I moved it around earlier, it's flipped back to that orientation as part of its assembly. Now, I need to rotate this. I've tried making another fixed joint between this one and this one. My expectation would be that this would flip around here and that would lock in. It's not what happens. It just creates a joint and they're not connected. So the best way I've found is I rotate this joint. And if you watch, I can rotate it. And as I'm rotating it, I can come around. Obviously, I want to go around to 90 degrees. I could just type in 90 straight in there if I wanted to. So if I go in here and just type 90, it automatically will get in there. Now, one gotcha. I've done this 100 times, so I know it's a gotcha. You think, oh, great, I've got this connected. And then you go off and do the next connection. If you don't click OK, it'll cancel the connection you had. So you've got to get in the habit of every time you do a joint and you're happy with it, click OK. Now what I also do is I click Save. And it asks you if there's an external file, do you want to save that as well? You can say yes. If you haven't made any changes to it, doesn't really matter. So that's a fixed joint. Now if I try and move that, it's not going to move from there. So that thing is locked solid. Now I want to show you what would happen if we used a revolute or a revolving joint. So the revolute will allow the rotation around a single axis. So it doesn't come in and out. Once you put those two faces together, they're going to be stuck and then it's going to be able to rotate. So I'm going to just show you that. I wouldn't normally use a revolute for this. I'd use this fixed one because that's what I actually want to happen. But I just want to demonstrate it. So I'm going to pick a revolute. One other thing I want to show you about that is if I'd picked the revolute, then I went, oh no, I want to get fixed. I can just drop down from here. I can change that to a fixed. And now it's just as if I selected this one, the fixed. So I'm going to go back to revolute. And I'm going to click this one, and I'm going to click on there. And now you can see that that one has located itself there. One thing with these parts is they don't obey any kind of boundary. What I mean by that is if I rotate this one, notice it's rotating on that point, it'll rotate right through that piece like it's not there. It doesn't know that there's a piece there. It doesn't know that if it comes here, it's got to stop. If I want to do that, I would have to set the minimum angle, maximum angle that allows it only to go around to where you want it to go. So if I said your minimum angle and your maximum angle is set, so I could do that where it hits. So let's say it's hitting there. I can set minimum angle. Now, how do I know that that's the minimum angle? Truth is, I don't. The only way I can find out is try and change it. So there I can see that it should be the maximum angle. I'm going to change that one. And now I can't go past there. Then my minimum angle would be this way. So that's the best way to find out, is to try it and see. Now I've fixed that. It won't go through that part because that's the angle that it can go to. One of the things that I like to do is to save every time. And then I also like to hit this solve assembly from time to time, because that will tell you if you messed up. It will, when you solve it, your part might flip somewhere else, and that means you didn't save your joint. Okay, so this one is on its joint. I'm just going to bring it back around here a little bit. I just want it to be there. But now I'm going to take this guy and just do a fixed joint on here, so that the two are together. So I'm just going to do that. And you can be, you don't have to zoom all the way in every time to be able to do this. So you can be at a distance. As long as you can see that the thing is connected in the right spot, you'll get it in there. And again, I need to do my rotation for 90. So I'm just going to go in there and type in 90. And I have a beautiful connection. So you can see that those guys are much better off with the fixed one than they are with this rotating one. Now I'm going to introduce the pins. So the pins go into these holes. And so I want to add those parts. I'm going to hit save again, because I want to save every time I make some progress. I want to save it, right? So now I'm going to go and get my pin, and I want to put 6 of these in. So I'm not going to locate them yet. I'm just going to put 2. And notice over here it's telling me how many I have inserted. So I've inserted 2, 3, 4, 5, 6. Those are my 6 pins. I'm going to say OK. And it just dropped them in randomly. I'll go over here, pick a pin. I can lift it up, move it over, get it ready to go into the hole. Get the second pin, pick it up, move it over, get it ready to go in the hole. Notice I'm not getting it too close because I want to be able to line up underneath there. So that's what I'm going to do. And I'm going to show you a couple of pins in the first one. And I'll zoom in here just a little bit so you can see. Now I'm going to do the first one. I'm going to do a fixed joint. So I'm just going to drop this into this hole. I'm going to do fixed joint into this hole. And then I'm going to go up here. I'm going to go into this diameter here. And when I do that, if I look, my pin is now in the hole. And it's jammed in the hole. It's not going to move from there. It can't move from there. It's not going to go in, out, do anything. So fixed is the easiest one. For a pin, though, it might be nice to have a revolute so that it can spin. So we can do that too. So I'm going to do the revolute on this one and pick that diameter. And I'm going to pick the diameter of the bottom there. I want to get the inner diameter. Got it. And then if you watch, you'll be able to see if we get it close in there. If I take hold of this, I can actually turn the pin. You can see it rotating, but I can't lift it out. It's not going to lift out from there. It's not going to push in. It's staying at that plane, but it can rotate freely. So that's perfect. We like that. Now we're going to go on to this one, and we're going to put his pins in, and we're going to do it with a different means of putting the pin in. So I'm just going to drag those over there. And this is the time for the cylindrical joint. I want to show you how that works. So again, I wouldn't use a cylindrical for this because it's not necessary, but I want to show you how it works. So I put the cylindrical on that top hole, and then I'm going to put the cylindrical under there again. I'm going to take a look at it. And there you can see my joint is there. And now if I grab this, I can lift it up and turn it. So I can do both. But the problem is I can also take it all the way down and it'll go inside that piece. Remember, in an assembly, it doesn't know that this piece is solid. It has no concept of that. But what you can do is you can set up a minimum length. And if that minimum length is set to 0, what's going to happen now is this will still come out. It'll still rotate, but it won't go down beyond where it originally went in. So it can't go inside, which makes sense, right? So you can pull the pin out, but it can't go inside. So I'm going to say OK to that one. And then for the rest of these, I'm going to use just the fixed because that would be the smart one, or the revolute, whichever one. If you want to have it move around like that, you can certainly do that. So then I have my assembly, I have my board, my 3 brackets, and I have my pins. Now, let's think about this middle one. Remember we let it rotate? Now I've got a pin in there, it won't rotate, right? Wrong. The pin doesn't know that there's anything there. So what I'm going to do is I'm going to put that roughly back in position. And now I'm going to go into the back of this pin on this side. And I'm going to put a fixed joint between this diameter and my pin. And there you saw it align itself. Say OK to that. Now if I come around here, now I try to rotate it. It's not going to rotate because that pin is actually locked to this. So it can't rotate anymore because the pin is locked to here from our revolute that we put in, and it's locked to this. So now this part cannot rotate anymore. So that's how you would do that. That's why I would use the fixed one, because with the fixed one, I don't need to do any second joint. With this one now, I've had to do an additional joint because I allowed it to rotate. But of course, it depends on your assembly and what you actually want to see. It's a perfectly fine situation to use a revolute if that's the way you want it to work. Okay, I'm going to save that. And I've got one more part I want to put in here. So this next part, I just go back to insert part. The next part is my faceplate. I'm going to add that. And what I'm going to do is just pull it out the way because I don't want it to be right inside there. So the faceplate just slides onto this thing. So I'm just going to say, okay, there's only one faceplate in this. And I'm going to do a slider joint. And so it's this one here. I'm going to select that. And I'm going to select this line. And I want that line to slide along here. So on this line. Now when I connect it, you can see it's on there. I'm going to just slide it. I can slide all the way through. Now if you watch, you can see my minimum and maximum over here are changing as I slide through. I want it to be able to slide about there, maybe a little bit more. So have it slide to there. So if I say that's my maximum slide, and then I bring it back this way. Oh, too far. Go there. We'll say that's my minimum slide. Now what's going to happen is my slider is locked on there, but it can still move. It can still slide around. So that's exactly how we want that slider to be. I'm going to say OK. And notice that it moved when I did that. If I say solve, it's still moved. What's going to happen is the first time I move it and bring it back, now it won't move off there. So it's back where it should be. And everything looks good there. I'm going to just zoom into that. And so now my slider can slide on my brackets, but it's fitted in there the way I want it to be. So that all looks good. And then I've just noticed that something is not right with that middle bracket there. So something is wrong with the joint, which is probably this pin joint is too far down. Yes, that's exactly what it is. This pin is pulling that down. So I need to break that joint for a second. So I'm going to do that. How do I break a joint? What I do is I can go up to my joint and I can go make my joint visible. And I think it's this fixed one because I'm going back. So this was the last one we put in the slider. So with this one, I can press spacebar and there's my joint there. So I know that that is it. So I'm gonna actually delete that. And you saw the bracket just popped back up. And now I need to figure out how do I lock that in without it pulling down. So there's another joint that we haven't used yet, but I can use it, which will do the same thing. So this joint is called a distance joint. So I'm going to use that. I'm going to say a distance from here to here. And I'm going to set that distance exactly like that and say OK. And now because that distance is set, that bracket shouldn't be able to rotate. So I'm going to try it. No, bracket doesn't rotate and it's upright and it's locked in. So as with everything in FreeCAD, there's more than one way to solve a problem. Again, we wouldn't have had that problem if we didn't use the Revolute over here. If we'd used a fix like this one and this one, that would have been fine right off the bat. But it's fixed now. Everything looks good. I'm glad that happened because it gave me a chance to show you how you can modify things without blowing everything up. Now, another thing I like that you can do with any FreeCAD model, actually, but with this one, it makes more sense because I have it in assembly. I'm going to give it a random color appearance. And what that's going to do is that's going to make my slider plate a different color, and I can do the same for my back plate if I want. So I can pick my back plate over here, random color. There we go. Now, if you don't like the random color that it picks, you go into my appearance and say this is going to be stone. And now it's a stone looking thing. So there we have it. Now, once you've got an assembly, there's a couple of things I think are really excellent that you can do. One of them that I particularly like is I'm going to set this into the middle. And I'm going to say create an exploded view. I'm going to explode radially. And then I'm just going to pull this out. And you can see the thing exploding, exploding, exploding. And now I have an exploded view of my assembly. And it's a great way for you to be able to label things. If you do that in a drawing, you can take this into a tech drawer drawing. And then you can label each of these parts. So if you were doing how to assemble this piece, you could actually call out each individual piece and be able to do that. Now, when I say OK, it all goes back to my assembly. If I want to see it again, down here it's created an exploded view. So for an exploded view, I open that one. Remember, if you've got an arrow pointing to the right, it means there's something inside there. So I'm going to click that, go to my exploded view, and I'm going to just double click the exploded view, and there it is again. And I'll say OK. Now, the last thing I want to show you, and I haven't covered every single icon, but I've definitely given you enough to get started with an assembly. But I want to show you the bill of materials because I think that's one of the reasons why people create assemblies, is so that they can create a simple bill of materials. So to do that, I just click on bill of materials, and it creates again another folder down here with the bill of materials in it. When I double click this, my bill of materials spreadsheet opens up, and it automatically includes the index. Now, I'm going to add column. I want to add the name, of course, and the quantity is going to be one of those important things to have. And if you look here, there's a column for description and one for file name. I'm not going to use those. And then you can add a custom column. Let me show you what happens when I do this. I hit there and I see the index, but I don't see my materials. I don't see their name. I don't see anything else. So I think this may be a small bugette that is in this assembly, this bill of materials. What I noticed is if you open it again, everything you added in is gone. I'll add those columns again. So I'll say name and quantity, but this time I'm going to add a custom column, and I'm going to call it notes. And now when I say OK, you can see my bill of materials actually worked. I have one back plate in there. I have 3 brackets. I have 6 pins and 1 faceplate. And then I have a column here where I can actually put notes. I can type whatever I want in there. It's just a spreadsheet. And then once I'm happy with that, I can export it. What I've been doing is I export it to Excel. So that's basically it. I don't want to go too crazy. I want to get you up and running with an assembly. If you have questions, which I'm sure there are many, if you have questions, feel free to leave a comment. I answer all the comments, and I will help you if you ask me a question. Also, if you have any suggestions for things you'd like to do, I think I'm about done with this bracket. I might actually use it in a 3D scanning video that I'm making. I might use the bracket as an example of how to do a 3D scan in the future. Once again, thanks for watching. Thanks for making it all the way to the end. If you haven't subscribed, it's free. Just press the subscribe button, and then you'll see all my videos as they come out. If you're interested in supporting the channel, you can always go to our Patreon, or you can join as a member on YouTube, or you can just buy us a coffee. Either way, everything works.